That's the divergence test. In fact, I think I may start calling it that because for some reason I can't seem to say the term test very well. Test term or whatever. Right? So my whole point in this is to encourage you to always try the divergence test first. And here, it doesn't always work. In fact, it doesn't even often work. But when it does, you save yourself a ton of time, especially compare how nasty that is. Okay? I don't know. I really don't even know how I would compare that to something else. All right. So that's that. All right. Now, let's look at something. I'm going to turn the page here. Let's look at something called the alternating series test. Or let's just start with 9.5. The title of the lesson is Alternating Series. Okay, alternating series. Here we are, Wednesday, 2:10. We won't finish today, but we will finish with enough time tomorrow. Listen, enough time tomorrow that I will take questions from you over any of the homework problems. And if I don't have questions, then I'm going to start making some extra ones up. So bring your questions. If you're doing the homework, you got to have questions. Because some of those even I don't understand. Okay? So, all right. So the reason that the alternating series is needed is because up to this point, every single series that we've looked at that mattered, all of the terms were positive. Okay? But we're not guaranteed for that to happen every time. There are some kinds of series called alternating series where the terms go positive, negative, positive, negative, positive, negative, or vice versa. So they alternate in sign. And when we have that type of situation, then we have a special way of handling those. Okay? All right. So let's write this down. Any series that has positive and negative terms is called an alternating series. Okay? And it would look like this. Okay? We'd like you to consider something that would look like this. The sum from n equals 1 to infinity, parentheses, negative 1/2 to the nth power. Okay? Now, what I'm going to do is I'm going to rewrite this because I'm going to factor out a negative 1. Okay? Now, what I'm going to be using is I'm going to be using this exponent property, that if I have two bases to the same power, I can separate each of those bases to that power. And the bases here are negative 1 and 1/2. So I'm going to write this as n equals 1 to infinity, negative 1 to the n power times 1/2 to the n power. Okay? Same exact thing. I can multiply them back together if I wanted to. I don't want to. And this is an alternating geometric series. Okay? Now, if the negative 1 wasn't there, this would be a clearly divergent geometric series because r is less than 1. But because of the alternating number there, it does not guarantee that it's going to converge or diverge. It doesn't guarantee convergence. So we have to treat these separately. Okay? And actually, the terms would look something like this. See, when n equals, actually, let's start this at n equals 0. Sometimes these start at 0. So just change that 1 to a 0. Now, anything to the 0 power is 1, so the first term would be 1. But notice, the second term, I would have negative 1 to the 1 power, which is negative 1. But then the next term would turn back positive, you see? Because negative 1 squared would turn positive. Then I'd get 1/4 minus 1/8 plus 1/16, and you can see the pattern. Yes, the numbers are decreasing, but the sign is changing on each one. See, thus, it's alternating. That's the title of the lesson, or the title of the series, alternating series. Okay? All right. So, how do we approach an alternating series, you ask? Well, we have an alternating series test. And here's what's really nice about alternating series. You can always find them. Because they're the only ones that have a -1 to some power.
Yay.
Okay. All right, now, there is one condition, and it's fairly easy. We have to let a sub n, that means every term in a sub n, be positive. Every term in the sequence is positive. Okay, I'll show you what I mean by that. Okay? Now, an alternating series would be, and I'm going to write it two different ways. The sum from n equals, say, we'll do 1 to infinity. You can do that. I can start wherever I want to. -1 to the nth power times a to the n. Or a sub n, a sub n, a sub n. Okay? A sub n. Now, the only restriction is that this particular sequence, forget about this part for a minute, that particular sequence all has to have positive terms. That's all. Okay? Which is really, you'll see in the examples, it really doesn't make any difference, but it's something that has to be added in. All right? Now, I do want you to notice here that all odd terms are going to be negative. Now, when I say odd terms, I'm talking about the first, the third, the fifth, the seventh, the ninth terms are all going to be negative. Got it? All the odd terms will be negative. You see that? Because anytime I have an odd power, a negative will be negative. Or the series could look like this. -1 to the n plus 1 power times a sub n. Now what's the only difference with this one?
Every even?
Yep. All the even terms are negative. Because if I put an even number in for n, I get an odd power. I get an even plus an odd is an odd. Okay? Alright, so these are what alternating series might look like. In fact, I've even seen it where it's -1 to the n minus 1 power. It really doesn't make any difference. As long as you have -1 to some power, it's an alternating series. Okay. Alright. Now, an alternating series converges if two conditions are met. Two conditions are met. And yes, you have to memorize them, and yes, this goes on our cold sheet. We'll update it tomorrow. 1, the limit as n goes to infinity of a sub n must equal 0. By the way, what if it doesn't?
Then it doesn't converge.
If it doesn't, it diverges, because that's really the divergence test. See, to do an alternating series, I have to apply the divergence test first. Okay? All right? But remember, the divergence test, just because it does equal 0, does not guarantee convergence. I have to test something else. So here's the real test. I don't like creating it here, but I will. Right? The n plus 1th term, okay? N plus 1th term must always be less than or equal to the nth term for all n. Now that is really the test. Okay? Here's one. Every single divergence or convergence test, whatever series, you've got to do you've got to do the nth term test first. Just make that happen. Okay? Now with alternating series, it's part of it. But you should just make that a habit. And you're going to start just like, well, it's on the previous page, you're going to start to see the ones that are very obviously divergent because the numerator will grow faster. Okay? All right. So, let's let's do it again. Okay. Again, the question is converge or diverge. Sum n equals 1 to infinity. -1 to the n plus 1 power.